Good afternoon, everyone. My name is Tim Rogers, and my thesis is based on the fact that you and I are lazy. Okay, maybe lazy is a little harsh, but let's just say that we're pretty good at minimizing effort. Consider the toast you had for breakfast this morning. I'm guessing you didn't bake the bread for that toast yourself. You probably bought it from the store because it's easier. My thesis focuses on making life easier for computer programmers. I want to make it easy for programmers to write code that runs quickly and consumes less energy on complex microprocessors. Freeing programmers from the burden of writing efficient code gives them more time to focus on creating new features and decreases the cost of everything that relies on software. You see, my field of research is computer architecture, where we study the design of the microprocessors found in your cell phone, your laptop computers, and in supercomputers throughout the world. Specifically, I study microprocessors that are capable of running thousands of tasks at once. Now, a task to a microprocessor could be something as simple as adding numbers together, or something as complicated as attempting to predict what you want to watch on Netflix next. Now, this ability to run many thousands of tasks at once can make these machines very efficient, provided the programmer puts in enough effort. You see, without the programmer's help, these machines are actually pretty poor multitaskers. And interestingly enough, the reason why they're poor multitaskers is the same reason you and I can be poor multitaskers. Studies in human psychology have shown that we have a finite amount of attention in our brains we can use to focus on any given set of tasks at any given time. If we attempt to switch between too many tasks at once, we exceed the capacity of this attention and our overall productivity suffers. It turns out the same is true in computers. Much like your attention, we devote a portion of the microprocessor to memory cells. If the programmer hasn't explicitly managed how many memory cells each task is using at any given time, then the computer will attempt to switch between too many tasks at once, and overall productivity will suffer. My thesis fixes this problem by making a computer a better multitasker. Part of my thesis proposes building a smart, on-chip hardware multitasker that uses feedback from these memory cells to actually detect when you're doing too much multitasking. When that happens, the multitasker scales back the number of tasks you're switching between such that they fit better in the machine's memory and overall performance increases. Effectively, by switching between less tasks at once, we're actually able to finish all of our tasks faster. Results using this hardware multitasker show that it's actually 5 times more efficient when running code that the programmer hasn't painstakingly optimized. This effectively frees the programmer from the burden of having to write efficient code, enabling them to focus on creating new applications and capabilities that can make all of our lives easier. Thank you.